Welcome to Scholars Academy. So now I have some questions with me, so I'll be solving it. So I want you guys to actually pay attention. Okay. So now the first question, see, which of the following situation is impossible? Now this question is under most. See, which of the following situation is impossible? Are you with me? Now we're actually talking about between acceleration and what? Velocity. Now let me explain something for you. Now, velocity and what? Acceleration. Normally, velocity and acceleration, they should go in the same direction. Take for instance now, if velocity is actually going towards east, are you with me? Acceleration also going towards what? East. That will bring an increase in what? Acceleration. Are you with me? You know we have acceleration and we have retardation, right? That will actually increase in acceleration, and that will be what? Positive acceleration. Let me put it positive acceleration. But if velocity, and this actually means there is increase in speed, are you with me? Since both of them actually go in the same direction. But if velocity is now going towards west and acceleration is now going towards what? East, this means that the speed, like the velocity, is actually decreasing. This is what this means, and that this will actually give us what? Negative acceleration, and that means retardation. So now look at this question. Are you with me? So they say which of the following situation is what? Is actually impossible. Look at the first Roman figure 1. Say that a body, the velocity and the acceleration both are in east. Let me put it out like the velocity is in east direction, the acceleration in what? East direction. Yeah, that's possible. That's what's correct. So what I mean, that means that acceleration will actually increase in that place. That's actually correct. Roman figure 2 say that velocity in the east direction while acceleration in the what? West direction. That's also possible. That actually means what? Retardation, and that means that the velocity is slowing down, or there's a decrease in what? Velocity. Now Roman figure 3, that actually tells us that what? The velocity is 0 and acceleration is what? Not 0. Now that's non-zero. Are you with me? The question is this really possible when velocity is actually 0? Like when velocity is 0 and the acceleration is what? Is non-zero. Is this possible? Yeah, that's possible. That's what's correct. Then what was the next one? The next one says that what? At constant velocity and variable acceleration. Oh, I'll jump. Roman figure 4. It states at constant acceleration and variable what? Velocity. What do I mean? That like acceleration is not changing, but velocity is what? Changing. Yes, that is constant. Now that is when we are talking about free fall. In free fall or in vertical throwing a body up, you all know that your velocity, like when you are throwing a ball, there's a decrease in velocity. When it's actually coming down, there's an increase what? In velocity. But does acceleration to gravity change? No. The acceleration of that body equals to what? Acceleration to what? Gravity. Because that body is on air, so it's now moving with what? Acceleration to gravity. And you all know that acceleration to gravity is what? Is constant. But the velocity what? We keep on changing, which means that this Roman figure 4 is also possible. Then let's look at Roman figure 5. It states what? At constant velocity and variable acceleration, that the velocity is actually constant. Are you with me? Then acceleration is now what? Variable. Now when velocity is actually constant, are you with me? Let me just say uniform velocity. Uniform velocity, will your acceleration be variable? No, obviously the acceleration should not be what? Variable. Are you with me? The acceleration will be equal to what? 0. So I've analyzed all the Roman figures, so I want you guys to drop the answer in the comment section. Tell me what will be the answer based on what I've actually explained now. Okay, let's move to the next question, which is question number. Okay, let me quickly go there. Now they say throughout a time interval, while the speed of a particle increase as it moves along the what? X-axis, its velocity and acceleration might be like they're actually trying to ask us what will happen to what? Velocity and what? Acceleration as times change. Are you with me? Along the what? X-axis. Now let me give you I've actually explained it here. You know I told you that if velocity and acceleration are moving in the same direction, are you with me? That means that the velocity is increasing and acceleration is also what? Increasing. But when velocity and acceleration are moving in the opposite direction, that means there's a decrease in what? Velocity. And when velocity decreases, what happens? There will be decrease in what? Acceleration. And that means what? Negative acceleration. Are you with me? So check that question also. Drop your answer in the comment section. Okay, 3. This is about mirror. Look at question 3. So question 3 it goes like this: an erect object in front of a convex mirror at a distance greater than the focal length. The image is. Let me come again. An erect object in front of a convex mirror at a distance greater than the focal length. The image is. Are you with me? Now, we all know that our convex mirror, normally give us virtual image. It is all virtual image. Didn't have that funny thing again? It will not erect and what? Diminish. Anytime you hear convex mirror, it will be all virtual, erect and what? Diminish. It will be all virtual, erect and what? Diminish. Are you with me? So the question popping on the screen, you should be able to answer your question there. So these are the people you need to just use this VED. Are you with me? VED. If you know that you can forget this VED, remember. V for virtual, E for erect, YD for diminish. So erect or upright. Are you with me? Now this image, you can also say that the image is actually smaller than the what? Than the objects. So the image is actually smaller than the what? Objects. An example where you can actually see this convex mirror, your Marwa, your keke, those 3 cycles, are using the mirror. They make use of a convex mirror. Why? Because it gives them a wider view. It's needed to see what? A wide view of something. Are you with me? That's why you notice that the mirror, they normally write it that object that is actually closer appear to be smaller. As the object is actually getting smaller, it means that that car or vehicle or whatever is getting closer to you. But when it is big, it means they are far from you. Okay, so that's question 3. So let's quickly go towards question 4. I hope you guys are getting what I'm actually saying there. Okay, now question 4 is also about mirror. Now this question asks that if an object is actually placed at the centers of curvature. So let me quickly just place at centers of curvature. That's at C. Are you with me? Now the image that will actually be produced will also be placed at what? It will also be formed at the centers of curvature. Are you with me? Now not only that, it will have the same size. Are you with me? With the what? Object. Same size and same distance. Now this actually explains why photocopy machine will actually give you the same size of font or of text that you want to actually photocopy. Why? Because the paper is placed at the centers of curvatures of the lens. Are you with me? So that's that. So you should be able to answer that question. That's a very straight question. Now the last question, they are asking for the unit, just like as you are seeing it on the screen there. They are asking for the units of what? Magnetic field. The units of what? Magnetic field. As we all know, your magnetic field, the symbol is what? Is B, right? Very good. Now we have the units for what? For magnetic field, right? The unit for magnetic field, that is letter B. This is magnetic field. So the units for this, so what will you do? You go to what? The formula, a formula that you can actually make it to get the unit very faster. That's what? Magnetic field equals to flux over what? Area. This is magnetic flux. Are you with me? So the unit for this magnetic flux is called Weber. Why the unit for area is what? Meter square. So joining two together, that will give you what? Weber per meter square or Tesla. So the name of the man that discovered magnetic field is called Tesla. Check it. So you call it Tesla or Weber per meter.